Okay, good morning everyone. I think we'll just give it another minute or two to allow any other attendees to join the webinar and then we'll get underway. Okay, good morning everyone. I think we have everyone we were expecting. So firstly I'd like to thank you for taking the time to join us this morning. Just by way of an introduction, I'm Martin Collins and I head up the Network and Security team at Ultima. Presenting alongside me is Andy Condliffe, who is one of Check Point's cloud security engineers. So we wanted to put this webinar together as more and more of our customers are moving to public cloud platforms, and it seems that the primary concern in doing so is security within that environment. So we wanted to invite Check Point along to give an overview of their VSEC technology, which is absolutely leading the way in this area. So just before I hand over to Andy, I just want to highlight some controls you'll find on your screen. So you'll see a little questions button on your right hand side. So if there are any questions as we go, we will take time out to answer them, but we'll also have a section at the end where we can take some questions as well. Okay, so without further ado, I'll hand over to Andy.
Good morning, everyone. Thanks for the introduction there, Martin. So, yeah, as Martin said, my name's Andy Condliffe. I'm a cloud security engineer for Check Point. So I sit in a sort of European specialist team focusing just on the VSEC product line for public and private clouds. So, and first of all, obviously the cloud's here. It's been around for a little while, and just some stats to give you an idea of what other people are doing. So in terms of adoption, 80% of enterprises are committed to having a cloud strategy by the end of this year. For next year, 40% of IT budgets will be cloud-based. But interestingly, the security is the main inhibitor for cloud adoption. So whilst we're seeing a lot of people moving to the cloud, security is still a concern and still something that is slowing the adoption. So why do we see people moving to the cloud? Primarily, it's the flexibility and cost of doing so. So what used to take weeks in the data center can now take minutes in the cloud. So again, as an example, some of the customers I work with, they can deploy test environments, pre-production environments in a matter of minutes with the same level of security and the same versions that they would in the production environment. So they can deploy in a matter of minutes, test, remove the environment, and then use the same templates, the same versions to create their new production environment, knowing that what they've tested and developed all along is going to be exactly the same as what goes into production, which is, again, as well as the speed and flexibility that gives you, that's not normally the case when you're relying on physical equipment. So that agility, that speed to be able to deploy and change the environment is one of the biggest reasons we see for people moving to the cloud. Also the elasticity, so the ability to quickly scale up and scale down as needed for spikes in traffic. So again, we see people like retailers who they know they're going to have spikes at certain times of year, Black Friday sales and so on, where their normal traffic will go to 4 or 5 times what they would normally see. So the ability just to deploy and grow the environment just to create with that, to be able to deal with those peaks sort of 2 or 3 times a year without having to invest in hardware and infrastructure is, again, is another key factor we see. But obviously, as we said earlier, security is an issue not just for cloud, but for data centers in general. So the perimeter gateway gives us that north-south protection. But typically, what we see is at least 80% of the traffic is east-west traffic, so traffic within the data center. So that lack of security between the applications is something that we've tried to address with VSEC, and customers want to see as they move to the cloud and they're rebuilding their environment. So they're taking that into account. So the ability to both detect those threats and block them as well. So that's one of the challenges that we looked at when we were building VSEC. Secondly is the dynamic nature, particularly with public cloud. The default is to use DHCP, so you have apps changing their IP addresses, you have things being taken up and shut down quite frequently. So the environments are very dynamic. So again, that raises challenges from a security point of view to effectively protect those. And particularly where you've got VMs that have been shut down for a period of time and they're brought up, they've got vulnerabilities. So having something there to protect them from the outside world is fairly critical. And the third challenge is the complexity. So most organizations are going to have a mixture of traditional infrastructure, some public infrastructure as a service, and possibly some private cloud as well. So each of those will have their own management platform. They'll have potentially their own security mechanisms. In the case of public cloud, there are certain security measures built in there, and they all require different skills, different knowledge, and provide different levels of control as well, which we'll come on to later. So looking at Azure itself, so Azure has 36 regions around the world, and then there's another 6 regions that are coming online shortly. So that gives organizations flexibility in where they can deploy. So the other thing to consider when you're moving to the cloud is the availability. So you can choose a region, but within each region, what Azure has is what they call fault domains. So equivalent in AWS, for example, of an availability zone. So this is hidden from the users, but when you create an availability set, it will automatically deploy into different fault domains. Now those fault domains could be in some cases separate physical data centers. That's not necessarily the case in all regions, so it could be just you're guaranteed that your machine will sit in a separate rack with separate hardware, separate power supply. So in the event of a partial failure, if you've got an availability set, and that's what we use, for example, for our Check Point clusters and auto scaling, it will make sure that if part of the infrastructure fails, your service, part of your service will still remain. So again, customers would typically want to do that. They've got a customer-facing website that needs to, high SLA in terms of availability. Then you'd look at making sure you're using an availability set, and then Azure will ensure that those individual machines are spread across multiple fault domains. So there'll be at least 2 fault domains, anything up to 5 fault domains depending on the region. And you'll see in the slide there you've got UD, which is update domains as well. So within the fault domains there'll be there's also update domains, and what therefore is obviously Azure need to maintain the integrity and patch the underlying infrastructure. So when they do that, they'll work on one update domain at a time, and once that's fully patched and fixed, they'll move on to the next one. So obviously, if that involves restarting the services, and you're in one update domain, you want to make sure that your other machines are protected from those kind of maintenance tasks that Azure will have to do periodically to maintain the integrity of the platform. Again, you don't have to worry about it. The availability set will take care of that and make sure that your machines are spread accordingly, and you've got that level of protection. So the next thing really is and we're not going to go into too much detail on this, but obviously it's fairly key to understand the terminology when you'll start to hear all these new terms. So having an idea of what they mean is obviously quite useful. So at the highest level, you'll have your tenancy, which is an AD representation of your organization. So you log into your tenancy, and then within there you'll have one or more subscriptions. And the subscriptions can provide two functions really. You can apply controls to it. So sometimes customers will have a sort of a subscription that's highly secure, very limited access, and lock that subscription down, and maybe that's where the security services sit, your AD sits, things like that. But it's also a means to billing. So when you get your bill at the end of the month, it's on a subscription basis. So some of the customers also use that to separate out departments. You have to be a little bit careful because having multiple subscriptions isn't really an issue, but there are certain things that if you do that, you have to replicate across the subscriptions. So if you have too many, you'll end up creating more than is necessary. The next thing you'll quite often hear about is a resource group. So when you deploy anything into Azure, whether that's a network or a virtual machine, it has to sit in a resource group. And the resource group is a container, and typically you use them to create to hold related resources. So when we deploy a Check Point cluster, for example, we'd have a dedicated resource group. The advantage of that is if you have to remember the cloud is seen as a disposable environment. So if I want to delete the cluster and redeploy a new one, if I delete the resource group, it will just get rid of everything associated with that instance. I can move objects between them if I want to keep addresses and things like that. But typically, you can also use it as well as a way of tying down permissions as well. So I can give a high-level access at the subscription level. The resource group would, by default, inherit that, but I can be more specific. So I can give people read access at the subscription level and potentially write access to their resources within a resource group as well. So virtual networks are really, that's just the representation of the network. So as you would internally, you will assign an RFC 1980 address, like on the slide 10.0.0/16, and that will be your CIDR for that virtual network, and then you can break that down into subnets to put your machines into. You can have multiple virtual networks as well. Again, customers will quite often use the virtual networks to separate out machines by function or department. Virtual machines, I hopefully don't need to explain that too much. It's just the compute instance. Availability sets we already mentioned, and as we said, it's just a method to increase the service availability. So you'll get a better SLA from Microsoft if you're using availability set, because you're spreading your machines across the physical infrastructure and potentially data centers as well. And finally, and probably the thing that causes the most confusion for people when they initially go is the Azure routing. So Azure comes with what's called system routes, the built-in routes, which effectively allow everything to, if I deploy a VNet and I deploy machines into subnets in there, the default routing would allow everything to see everything else in terms of routing, taking security aside for a second. And also, by default, everything would be given internet access. Whether it actually works or not depends on whether you have a NAT device or you associate a public IP to a specific machine. But what you generally do then is create your own user-defined routes, and it merges those with the system routes to create the routing table. And I can use the user-defined routes, for example, to start routing my subnets and my traffic through my security gateway, so that I can start to protect them properly from the internet and from different subnets from each other. Obviously, Ultima, we work quite closely with Ultima. Ultima has teams of architects that can help with this. So again, reach out to those guys, and that they can help with migration plans and through to sort of fully managed services. The next question you're probably going to want to consider is, how do you connect to your new cloud? And there's two options really. There's ExpressRoute, which is a Microsoft service effectively. So you'll buy a circuit from your telco, and there's, I don't know, 40, 50 telcos in the UK, the usual suspects that can provide you with this. And it's basically an MPLS link from on-premise into your Azure instance. And that allows you to route your private address space that you've got within your virtual network to your on-premise. So you can route between them. There's actually 3 types of peering they give you on an express route. One is that private peering. The second is the public peering, which refers to your public IPs that you're using, so for your public-facing website, for example. And then the third peering is Microsoft IPs, which is things like Office 365. So again, I mean, the advantage with the express route is you'll get an SLA, you'll get you can take sort of pay for unlimited usage and things like that. So it's a way of connecting into Azure, into your environment. The second option is, I guess what a lot of people use, particularly initially, is just VPN access. So from your site to the Azure, either to Azure VPN gateway, so Azure gives you the option to terminate VPNs on their own VPN instances, or to a security appliance such as the VSEC gateway, so you can do just a traditional IPsec site-to-site VPN. When you're considering moving to Azure, I guess that some of the things you want to consider is which regions. We've got the 36 regions out there, so which regions you want to use. And a lot of the customers I work with, the UK is a fairly new region to Azure, and it's tended to be slightly more expensive, so I see a lot of people using Western and Northern Europe because it's slightly cheaper. But it depends on things like GDPR may change that, but yeah. How many subscriptions are required? So how are you going to separate and how are you going to bill? And like I said before, it simplifies the billing, but it can increase the complexity. So I see a lot of customers with 1 or 2 subscriptions, but not beyond that. You'll start to create work for yourself. So just again keep that in mind. And then the availability. So what availability you're looking for in Azure. So you can design around things like using the availability sets, potentially auto-scaling for both your web service, for example, but also your security services as well, so they can scale up and down with peaks and troughs in demand. And do you want active-active across regions? So again, Microsoft offer you the Azure Traffic Manager, so you could have 2 regions, UK and US region, for example, and it can balance or do failover and route the traffic to those regions. So again, you can use 2 regions at the same time, active-active, if you have something like the Traffic Manager, or you could use Akamai or one of the third-party content delivery networks to do the same thing, I guess. So moving on to VSEC itself. So VSEC, we have the VSEC gateway, but there's actually 2 components to VSEC really. So there's the VSEC gateway itself, which is just a virtualized version of Check Point's appliance solution. And then we have the VSEC controller, which allows us to do automation with the cloud platform that we're integrating with. On the gateway side, we support all the normal blades that you would see on a typical Check Point appliance. So we can, as well as the firewall, we've obviously got things like the IPS, the anti-bot, antivirus, threat emulation. So all the features that you would have on a physical appliance, you can have on a VSEC appliance in Azure. The VSEC controller is effectively a plug-in into either your management server, your existing one if you're an existing Check Point customer, or if you're a new customer, it's just part of the management server. So what that VSEC controller allows us to do is to actually query the APIs of the different cloud platforms and select objects from within those cloud platforms and start to use them within the policy. Not only that, we're going to poll those objects every 30 seconds because they may change. As we said earlier, if you've got things on a DHCP environment and it comes up with a different IP, it will still match the policy. So within 30 seconds of us picking that change, we'll automatically update the gateway. So once if you like, the logic is in place, the IPs will change dynamically. So as the changes occur, we pick those up, we update the gateways. In terms of the solution portfolio, so obviously we're not just restricted to Azure, we integrate with VMware NSX, Cisco ACI, Amazon Web Services, Azure, OpenStack, nuanced networks. Generally, we see that with OpenStack as a way of introducing an SDN to do things like microsegmentation. Google Cloud Platform and Ali Cloud, not that I see much of that in Europe, but it's there. Another key thing here is, as customers deploy physical machines, VSEC into public cloud and private cloud, the management center gives us that unified management and unified visibility. So I can apply a consistent policy across all these environments. I can use the same policy across everything, or I can create separate policies, but I can do it from one place. I can see all the controls, and I get all the logging information and alerting back to my single location. So again, from a security perspective, your security staff only need to learn that one platform, and they can secure the public cloud, private cloud, physical, traditional infrastructure, and so on. And what it allows us to do, the VSEC allows us to do, as I said earlier, is this application-aware policy, if you like. So we can query the different integrations, the different cloud platforms, and we can pull those objects into the policy. So, for example, in the one on the screen here, Rule 3 is pulling a virtual machine name from vCenter, allowing access to a database group in security group within NSX. And once I've pushed that policy, if I then added another machine to that database group, for example, within 30 seconds, we'd pick that change up and we'd update the gateway. So that would happen automatically without an administrator having to do a policy push. If you look at Rule 5, and this is one of the things we typically use in Azure and AWS in the public clouds, we use tags. So I can create a tag, for example, internet allowed equals yes, and only machines that have been have that tag would be given access to the internet. So I can have a drop rule after that, and I can control which specific machines have access to the internet. And also, again, as new machines come up and given that tag, then they would match that rule. So it does introduce kind of new concepts in terms of you've got to potentially rethink how you control machines and tagging machines, because they can obviously influence the access that's given to the machine. Obviously, I can do it in other ways, like using machine names, subnets, and so on. But it's a simple way with the cloud of grouping things together. So we do that using what we call data center objects. And as you see, I've got a screenshot here. It's really just a way of identifying the API. We don't need to do that in Azure's case because it's a standard API. But if it was an on-premise appliance for NSX, we'd just give the IP address or machine name, and then an authentication method. So for Azure, I can use either service principals or AD accounts. Typically, I use service principals because they gives you slightly better security, and that you can't use that through the GUI. It's just an API account. And in this case, it only really needs read access, because what we're trying to do is log into Azure, select objects that we've created or subnets we've created, and then pull those into the policy. So any need read access to do that. And you'll see at the bottom there's a test connection button. So having put the credentials in, I can test, make sure it's working, make sure that it's able to log in and see the information. And that will allow me to create objects within the policy. So I've got an example here with a couple of objects on allowing access between this Windows machine, which I've just used the actual virtual machine name here, and that's allowed access to a web server. Again, you'll see in this case I've done full microsegmentation. So even though these two machines are on the same subnet, I can still, using the user-defined routes, I can route that traffic to the gateway and still apply inspection. Most customers aren't going to go full microsegmentation. It's quite complex, but typically customers will separate the subnets out. So each subnet would go via the VSEC gateway to be inspected, and again, we can do all deep packet inspection. We can do apply the full range of traffic control that we have on the physical gateway in Azure. And the second object in that rule is again using a tag in this time. So anything that has the type of web server, then that machine is able to communicate with it via SSH in this case. And those objects, we're polling those every 30 seconds. So where you see where I've hovered over the object and it's showing the IP, for the tag, if it was there was more machines tagged, you'd see more IPs, and you could scroll down through them and see what they were. So there's three main deployment methods with Azure. You've got the Azure portal, which is through the web GUI. So you can select images, you can deploy those images and manage everything through that portal. You can also create solution templates. A solution template is going to be it's a JSON file, and you can take, in the case of Check Point, for example, if you go through the deployment, the final stage before you deploy, you can actually download the JSON configuration for what you've configured so far, use that as a template or customize it, and then re-upload it so that your customized deployment is just a single click through the GUI. You could also use that JSON file and do it through the API with a Python script or plug it into an Ansible server or whatever orchestration tool you're using. The third option is to use Azure PowerShell. So again, PowerShell has extensions that allow you to communicate with Azure and create machines, log into Azure, create objects, and so on. Personally, between the two, if you can use the JSON, it's more efficient. Azure PowerShell is going to go through one command at a time, complete the first command, then run the second command, and so on. If you're using the solution templates, if there's multiple tasks, it will try and run those in parallel. So if you're doing a lot of this, then using the solution templates and JSON is a more efficient way to do that. So in terms of architecture options for VSEC, we can do a single gateway. So we can provide the same sort of protection as you would for, say, a website, for example, on physical infrastructure. So we would sit in between the machines and the internet. We'd update the routing to send the traffic through the VSEC gateway, and then we can do the NAT, we can do the protection, we can do all the things that we would typically do. And we can also use that adaptive, again, the adaptive policy to control traffic flow, to the number of, to define which machines are web servers. Typically, it would get slightly more complex than this. Customers start to deploy load balancers and things like that. But at the simplest level, that's what it would look like. The second option is a cluster, so a VSEC cluster. Functionally, it's going to work in pretty much the same way in terms of traffic flow as the single gateway. I guess the difference is you've got that HA, and those machines are deployed in an availability set. So again, if part of a particular region fails, hopefully being in a different fault domain, those if one machine goes down, the other should survive. The third option is the auto scale set. So typically we use this for web, for peaky websites, but we have customers using it for other things as well. There are some limitations in that the machines are auto deployed by Azure, so we don't, and they're deployed on private IP space. So we put a load balancer in front of them, so we can't do things like VPN termination because we don't know the machine that's going to be running and things like that. But the way it works is you'll define a minimum number of machines, so 2 is the minimum normally, and a maximum, say, 10. And then Azure monitors the performance of those and the load on those machines. And as the demand picks up, it will automatically deploy a third, a fourth, a fifth, up to whatever your limit is, to cope with those peaks. And you'd have auto scaling as well on your web backend as well to cope with obviously to cope with the traffic. And then when the peak is over, it will automatically shut those down. And the process involved, it will connect to the management server, it will set up secure communication, and it will pull a policy. And once it's got the policy loaded, it will be added to the group. So again, this is completely automated. And it'll allow you to kind of scale up and scale down for sort of events where you're going to see sudden rises in traffic. I haven't really talked about licensing, but we offer 2 models: pay-as-you-go or bring your own license. Bring your own license is usually it's the traditional method. You buy a license, and you renew that annually. The pay-as-you-go is more often than not used in things like autoscale. So I don't want to pay for 10 licenses if 90% of the year I'm only running on 2. So we support both models, but typically pay-as-you-go is we see it most in these kind of environments where you're going to scale up to a lot of machines, but only for a short period of time. So in terms of securing the environment, the steps that we would say you should follow is first to protect the perimeter. So use advanced threat protection such as VSEC to protect you at the cloud perimeter, and to make sure that you're blocking malware, and you have you've got your IPS and the levels of protection you need to protect traffic coming in and out. And also to allow you to securely connect to your cloud if you're doing it over VPN or VPN client. The second step is to segment the cloud. So like I say, most customers would do that on a subnet by subnet basis. So each subnet has to go to the gateway to check policy for the packets to be analyzed before it goes to the next subnet. We can do, as we showed you on the earlier screenshot, you can do full micro-segmentation. So within a subnet, I can still make machines. If web server 1 wants to talk to web server 2, it has to go to the VSEC gateway. So typically customers would use that for sort of internet-facing machines. Generally speaking, most people don't do that for every machine. You've got to take into account load on the gateway. If you're going to send every single packet through, that's quite an overhead. But you can be fairly flexible with that. So as you segment the traffic, if something malicious does hit, we should be able to isolate that app from the rest of the network and stop that the spread of that lateral threat between the different subnets and between the applications and machines that you have there. Third step is, as we said, this consistent security policy. So again, having the ability to have a single management server for your on-premise and your cloud means we can apply a consistent policy and consistent level of control across all your environments, so across all your resources. The idea with VSEC really is sort of any service anywhere, any cloud platform, we should be able to deploy into there, and we should be able to provide protection. And obviously, one of the outcomes of that is a reduction in the operational cost. If your guys need to be expert in one platform, one solution, it's a lot easier than having to be experts in 4 or 5, and both from a cost point of view and an efficiency and security point of view as well. And then step 4, which is probably more, for some customers is more of a longer term goal, is to automate it. So our management server has the API, so you can automatically create objects, push policy. So we can do auto provisioning of both gateways, policies, and obviously objects within Azure. We can do the auto scaling, and then we've got this adaptive changes as well by using the VSEC controller to monitor objects that already exist. And if we see new machines, IPs changing, machines added to groups, or additional tags added, they will automatically match the policy. We'll pick those changes up, and IPs will change automatically without you having to do anything. So all the cloud vendors do offer a level of security within the platform. So why not use the network security groups that come with Azure, for example? I mean, the main reasons really here are that the native security solutions, and this applies to AWS as well, they're really just working up to layer 4. So they're source, destination, port number, type, controls. Sometimes they're stateful, sometimes they're not, depending on where they apply. You can apply them on the subnet level or the machine level, but they're not protocol aware. So if I am allowing port 80, I hope that's web coming in, but it could be SSH, it could be anything on port 80. It's port 80. It doesn't, it has no context in terms of protocol. It's just a port number. There's no single console view of the policies either. So managing and troubleshooting can become quite cumbersome if you're using a lot of different policies and security groups on both the subnet and the machine. So you're having to jump around and see what you've got, and there's no kind of central view. You'd have to look at each security group or each machine individually to understand what's happening. The other key thing, particularly with Azure, is that the native offerings only allow you to specify IP addresses. So again, a lot of customers would maybe use something like a SQL PaaS service that sits outside your infrastructure. So with VSEC, Microsoft would give you a fully qualified domain name, so my customer name.sql.microsoft.net or whatever it happens to be. I can use that FQDN in my VSEC policy, and I'll dynamically check it every time I see a packet, so that I know it's always going to work. It's always going to be valid. because while the FQDN stays the same, the IP behind it will change periodically. So if all I can do is put an IP in, then I'm going to find out every now and again that my rule doesn't work. My access out to that site just stopped working, and I'll have to go and manually change it again. So again, it's not an ideal way to do it. The other thing, which again Microsoft does warn you about this, but when you create a security group, there are built-in security rules that don't display. You can view them when you look at an object and ask to see its effective security groups, but if you create a security group, the moment you turn it on, these built-in ones will apply. So again, and they're default inbound and outbound rules. So you'll see it has a numerical value, and the lower the number, the higher the preference. So you can obviously overwrite these if you don't want them, but if you don't know they're there, or if you forget, then again you can end up with controls that you didn't think you had, or holes that you didn't think you had, which is probably more of a concern. So in terms of why I would say choose, why you should look at VSEC over our competitors, firstly, the trusted policies allegation. So when we introduced R80, which is an R80.10, which is now our new latest version, we made quite a few changes. We introduced the API, we allowed multiple administrators, and we also introduced the concept of sub-policies. So I can give an administrator, or more importantly, an orchestration tool, access to just a part of my policy, and it allows you to create very granular role-based access control. So I can give very specific scope in terms of privilege, just to certain rules or certain sections of the policy. And again, most of our competitors, if you have the ability to change the policy, you have the ability to change the entire policy. Second reason is the simultaneous updates. So as we move to allowing multiple administrators, obviously a key thing then is to ensure the integrity of the policy and the objects. So we introduced the concept of locking them either an individual object or a rule, depending on what you're doing. So while someone's working on a rule or an object, it's locked for everybody else until they publish that change. So we can do simultaneous updates, but knowing that the integrity of the data is going to be maintained, and you don't end up in some kind of race condition where whoever clicks save last overwrites what the other guy's just done. So again, maintaining the integrity of the policy is critical. And the third reason is the dynamic changes, both in terms of the ability to use the API to centrally change things, but also with our adaptive controls with the VSEC controller. So we're constantly monitoring on all the different platforms, and those objects I can use outside in my virtual world. So if I've got an express route link, for example, into Azure, I can use the objects from Azure on my physical gateway as well. So we're not just restricted to the virtual machines. Because they're a function of the management server, they can be used on any device any gateway that management server controls. So it will do the polling and the monitoring, and it will update the gateways with that information. So finally, in summary, we can provide advanced security for the hybrid cloud. You have public cloud, private cloud, and obviously your traditional on-premise equipment. We can give you that automation both through the VSEC controller and through the APIs we provide within the product, and the unified control and visibility across all those environments. So at that point, I'd like to thank you, and if anyone's got any questions, please ask them now.
Thanks, Andy. Been quite quiet so far with questions, but as Andy said, if you have any questions, you'll see the little window on your right-hand side. Just get them answered as we go. I've just got a quick question for you, Andy. If someone would like to get started with VSEC and put it into their Azure environment, how easy is it to get started, and where do you go from there?
So it's quite simple. Normally most enterprises will be given, if they're already a Microsoft customer, they'll be given an amount of credit. But even as an end user or private user, you can sign up. They'll give you £150 of credit, so you can start to play the checkpoint boxes. If you choose bring your own license, you'll get a 15-day eval license by default on the gateways and management. So you can deploy a whole environment. And if you want to take that further, we can give demo license and extend that. You know, you can contact Ultima or ourselves, and we'll extend that for you. And also, you know, my role here is to work with customers to help with POCs and you know, help enable customers. So again, I'm happy to assist, you know, via WebEx, via phone call, on site, whatever. If you need help in understanding how it works or deploying, again. But yeah, go and have a play. You can sign up, create your virtual network, start to deploy some machines, and get an understanding. And it's not going to cost you anything. So yeah, well, give it a go.
Great. Okay, so it looks like we don't have any questions. So I'd like to thank you all for joining us. I want to thank Andy for his excellent presentation. By way of a call to action, I'd like to invite you to meet with Ultima's security consultants and team of cloud architects. We can help with your discussions and your plans to deploy your Azure environment. If you would like to explore the VSEC solution, as we said, it is available to trial. We can help you come in and set up a POC as well. So these slides will be made available by our marketing team, and we'll send them out to you. So thank you again for joining us, and hopefully we'll speak to you soon.